Hello everyone, I am D. Harita. In this video, we are going to learn about the implementation of BFS traversal for a given graph. Traversing the graph means visiting all the vertices of the graph. There are two graph traversal techniques, BFS, breadth first search traversal technique, and DFS, depth first search traversal technique. In this video, we are going to learn about BFS traversal technique. Breadth first search is a graph traversal algorithm. It starts traversing the graph from a selected source node and it explores all its neighboring nodes. Then it selects the nearest node of the source node and it explores all the unexplored nodes of that particular node. This process continues until all the nodes of the graph are visited. To implement the BFS traversal technique, we use a queue data structure. Here are the steps to implement the BFS traversal technique. Step 1. Define a queue and take the size of the queue equal to the total number of vertices in the graph. Step 2. Select any vertex as a starting point for traversal. Visit that vertex and insert it into the queue. Step 3. Visit all the non-visited adjacent vertices of the vertex which is at the front of the queue and insert them into the queue. When there is no new vertex to be visited from the vertex which is at the front of the queue, then delete that vertex from the queue. Repeat the steps 3 and 4 until the queue becomes empty. Here is an illustration for BFS traversal technique. Consider a graph with 6 vertices and 8 edges. Initially, visited status of all the vertices is 0 and queue is empty. Start traversing the graph from vertex 1. So visit 1 and add it into the queue. Now 1 is at the front of the queue. Visit all the non-visited adjacent vertices of 1. Here the adjacent vertices of 1 are 2 and 3 which are non-visited. So visit 2 and 3. After visiting 2 and 3, print 1 and delete it from the queue. After deleting 1 from the queue, insert 2 and 3 into the queue. Now 2 is at the front of the queue. Visit all the non-visited adjacent vertices of 2. Here the non-visited adjacent vertices of 2 are 4 and 5. So first visit 4 and 5. Now print 2 and delete it from the queue and add 4 and 5 into the queue. Now 3 is at the front of the queue. Visit all the non-visited adjacent vertices of 3. Here the adjacent vertices of 3 are 1 and 5 which are already visited. So there is no new vertex to be visited from the vertex 3. So print 3 and delete it from the queue. Now 4 is at the front of the queue. Visit the non-visited adjacent vertices of 4. So here the adjacent vertex of 4 which is not visited is 6. So visit 6. Print 4 and delete it from the queue and insert 6 into the queue. Now 5 is at the front of the queue. So there is no new vertex to be visited from 5. So print 5 and delete it from the queue. Now 6 is at the front of the queue and there is no new vertex to be visited from 6. So print 6 and delete it from the queue. Now the queue is empty and all the vertices of the graph are visited. So the order of traversal here is 1, 2, 3, 4, 5, 6. Here is the pseudocode for implementing the BFS traversal technique. Consider a graph G and S is the source node. Let Q be the queue. So first step is Q dot NQ of S, that is insert the source node S into the queue and mark S as visited. While Q is not empty, so first remove the vertex which is at the front of the queue. So and store it in V. Now for all the neighbors of V, here the W is considered as a neighbor of V in graph G. If that W, which is a neighbor of V, is not visited, so insert that W into the Q, that is Q dot NQ of W. Then mark the W as visited. Repeat this process until all the vertices of the graph are visited. Here is the implementation of BFS traversal. Enter the number of vertices n, enter the number of edges m, and also mention the edges. Then enter initial vertex V. First visit that vertex V, so visited of V equal to 1, while k is less than n, that is number of vertices. For j equal to 1, j less than or equal to n, j plus plus. If visited of j is not equal to 1 and visit of j is also not equal to 1, then visit that particular vertex j. So visit of j equal to 1 and add that j into the q. So q of rare plus plus equal to j. This loop is repeated. This for loop is repeated until all the neighboring vertices of V are visited. Then V equal to q of friend plus plus, that is when there is no new vertex to be visited. We are deleting it from the Q and we are storing it again in V. Now print V. Next k plus plus, move to the next element in the Q, and this process is repeated until the Q becomes empty and all the vertices of the graph are visited. This is the output we are going to get when we execute that particular program. First enter the number of vertices. Here I am entering the number of vertices as 5 and number of edges as 10, and even I am giving the edges, that is 1, 2, 1, 3, 1, 4 and so on. Enter initial vertex. Here I am entering the initial vertex is 3. So after traversing, it is going to generate the order of visited vertices, that is 3, 1, 2, 4 and 5. So this is about the BFS graph traversal technique. Thank you.